Mount Pinatubo. From Wikipedia, the free encyclopedia, http://en.wikipedia.org. Mount Pinatubo is an active volcano located on the island of Luzon in the Philippines, at the intersection of the borders of the provinces of Zambales, Bataan and Pampanga. Before 1991, the mountain was inconspicuous and heavily eroded. It was covered in dense forest, which supported a population of several thousand indigenous people, the Aita, who had fled to the mountains from the lowlands when the Spanish conquered the Philippines in 1565. The volcano's recent eruption in June 1991 came after 500 years of dormancy, and produced one of the largest and most violent eruptions of the 20th century. Successful predictions of the onset of the climactic eruption led to the evacuation of tens of thousands of people from the surrounding areas, saving many lives, but the surrounding areas were severely damaged by pyroclastic flows, ash deposits, and later lahars caused by rainwater remobilizing earlier volcanic deposits. Thousands of houses were destroyed. The effects of the eruption were felt worldwide. It injected large amounts of aerosols into the stratosphere, more than any eruption since that of Krakatoa in 1883. The aerosols formed a global layer of sulfuric acid haze over the following months. Global temperatures dropped by about 0.5 degrees Celsius, or 0.9 degrees Fahrenheit, and ozone destruction increased substantially. Section 1. Overview of the Mount Pinatubo area. Pinatubo is part of a chain of volcanoes which lie along the western edge of the island of Luzon. They are subduction volcanoes, formed by the Eurasian Plate sliding under the Philippine Plate along the Manila Trench to the west. The word Pinatubo means to have made grow in the Tagalog and Sambal languages, which may suggest a knowledge of its previous eruption in about 1500 AD, although there is no oral tradition among local people of earlier large eruptions. Pinatubo might instead mean a fertile place where crops can be made to grow. Before the catastrophic eruption of 1991, Pinatubo was an inconspicuous volcano unknown to most people in the surrounding areas. Its summit was 1,745 metres, or 5,725 feet above sea level, but only about 600 metres above nearby plains, and about 200 metres higher than surrounding peaks, which largely obscured it from view. An indigenous people, the Aita, had lived on the slopes of the volcano and in surrounding areas for several centuries, having fled the lowlands to escape persecution by the Spanish. They were a hunter-gatherer people who were extremely successful in surviving in the dense jungles of the area. In total, about 30,000 people lived on the flanks of the volcano in barangays or villages and other small settlements. The dense jungle covering most of the mountain and surrounding peaks supported the hunter-gathering Aita, while on the surrounding flatter areas, the abundant rainfall, almost 4 metres annually, provided by the monsoon climate and the fertile volcanic soils provided excellent conditions for agriculture, and many people grew rice and other staple foods. About 500,000 people continue to live within 40 kilometres of the mountain, with population centres including the 150,000 in Angeles City and 20,000 at Clark Air Base. Several important river systems have their sources on Pinatubo, with the major rivers being the Bacau, Santo Tomas, Maloma, Tanguay and Keleng rivers. Before the eruption, these river systems were important ecosystems, but the eruption filled many valleys with deep pyroclastic deposits. Since 1991, the rivers have been clogged with sediment, and the valleys have seen frequent lahars. Studies show that the river systems will take many years yet to recover from the 1991 eruption. Section 2. Geological History. Although there seems to be no local knowledge of the previous large eruptions in the Pinatubo area, several Aita residents reported in 1991 that their elders recalled small explosions in the past. Pinatubo was a known geothermal area before the 1991 eruption, and small steam explosions are quite common in such areas. It was only after volcanic activity began in 1991 that geologists studied the eruptive history of the region in any detail. Eruptions at the site can be divided into two major eras. Ancestral Pinatubo. Much of the rugged land surrounding the present volcano consists of remnants of ancestral Pinatubo. This volcano was located roughly in the same place as the present mountain, and activity seems to have begun about 1.1 million years ago. Ancestral Pinatubo may have reached a height of up to 2,300 metres, or 7,550 feet above sea level, based on profile fitting to the remaining lower slopes. Several mountains near modern Pinatubo are old satellite vents of ancestral Pinatubo, formed from volcanic plugs and lava domes. Some nearby peaks are also remnants of ancestral Pinatubo, formed from erosion-resistant parts of the old mountain slopes left behind when the less resistant parts were eroded away by weathering. The eruptive activity of ancestral Pinatubo was much less explosive than modern Pinatubo, and probably ended about 45,000 years ago. After a long period of dormancy, modern Pinatubo was born in eruptions beginning about 35,000 years ago. Modern Pinatubo. The birth of modern Pinatubo occurred in the most explosive eruption in its history, which deposited pyroclastic flow material up to 100 metres thick on all sides of the mountain. The total volume of material erupted may have been up to 25 cubic kilometres or 6 cubic miles, and the removal of this amount of material from the underlying magma chamber led to the formation of a large caldera. Later large eruptions occurred 17,000, 9,000, 6 to 5,000, and 3,900 to 2,300 years ago. Each of these eruptions seems to have been very large, ejecting more than 10 cubic kilometres of material and covering large parts of the surrounding areas with pyroclastic flow deposits. Scientists estimate that the most recent eruption before 1991 happened about 500 years ago, and after that the volcano lay dormant. Its slopes became completely covered in dense rainforest and eroded into gullies and ravines. Section 3. 1991 Awakening. On July 16, 1990, an earthquake of magnitude 7.8, comparable in size to the 1906 San Francisco earthquake, struck central Luzon. Its epicentre was about 100 kilometres northeast of Pinatubo, leading some volcanologists to speculate that it might ultimately have triggered the 1991 eruption, although this is impossible to prove conclusively. 2 weeks after the earthquake, local residents reported steam coming from the volcano, but scientists visiting the mountain found that small landslides rather than any eruptive activity were responsible. On March 15, 1991, a succession of earthquakes was felt by villagers on the northwestern side of the volcano. Further earthquakes of increasing intensity were felt over the next 2 weeks, and it became clear that some kind of volcanic activity was imminent. On April 2nd, the volcano awoke, with phreatic eruptions occurring near the summit along a 1.5 kilometre-long fissure. Over the next few weeks, small eruptions continued, dusting the surrounding areas with ash. Seismographs detected hundreds of small earthquakes every day. Scientists immediately installed monitoring equipment and analysed the volcano for clues as to its previous eruptive history. Radiocarbon dating of charcoal found in old volcanic deposits revealed the 3 major explosive eruptions in recent millennia, about 5,500, 3,500 and 500 years ago. Geological mapping showed that much of the surrounding plains were formed by lahar deposits from previous eruptions. Volcanic activity increased throughout April and May. Measurements of sulfur dioxide emission showed a rapid increase from 500 tonnes per day on May the 13th to 5,000 tonnes per day by May the 28th. This implied that there was a rising column of fresh magma beneath the volcano. After May the 28th, the amount of sulphur dioxide being emitted decreased substantially, raising fears that the degassing of the magma had been blocked somehow, leading to a pressure build-up in the magma chamber and a high likelihood of explosive eruptions. The first magmatic eruptions occurred on June the 3rd, and the first large explosion on June the 7th generated an ash column 7 kilometres or 4.5 miles high. The Philippine Institute of Volcanology and Seismology, or PHIVOLCS, led by Raimundo Panongbian, issued a warning indicating the possibility of a major eruption within 2 weeks. Section 4. Evacuation. Given all the signs that a very large eruption was imminent, PHIVOLCS worked in cooperation with the US Geological Survey to convince people in the local area of the severity of the threat. A false warning may have led to cynicism about any later warnings, while delaying a warning until an eruption began might lead to thousands of deaths, so the volcanologists were under some pressure to deliver a timely and accurate assessment of the volcanic risk. 3 successive evacuation zones were defined, the innermost containing everything within 10 kilometres of the volcano's summit, the second extending from 10 to 20 kilometres from the summit, and the third extending from 20 to 40 kilometres from the summit. Clark Air Base and Angeles City were in this zone. The 10-kilometre and 10 to 20 kilometre zones had a total population of about 40,000, while some 331,000 people lived in the 20 to 40 kilometre zone. 5 stages of volcanic alert were defined, from Level 1, low-level seismic disturbances, up to Level 5, major eruption in progress. Daily alerts were issued, stating the alert level and associated danger area, and the information was announced in major national and local newspapers, radio and television stations, non-governmental organisations, or NGOs, and directly to the endangered inhabitants. Many of the Aita who lived on the slopes of the volcano left their villages of their own volition when the first explosions began in April, gathering in a village about 12 kilometres from the summit. They moved to increasingly distant villages as the eruptions escalated, with some Aita moving up to 9 times in the 2 months preceding the cataclysmic eruption. The first formal evacuations were ordered from the 10-kilometre zone on the 7th of April. Evacuation of the 10 to 20 kilometre zone was ordered when a Level 4 alert was issued on the 7th of June. A Level 5 alert triggered evacuation of the 20 to 40 kilometre zone on the 14th of June, and in all some 60,000 people had left the area within 30 kilometres of the volcano before the 15th of June. Most people temporarily relocated to Manila and Quezon City, with some 30,000 using the Amaranto Stadium in Quezon City as a refugee camp. Section 5. Eruptions build to a climax. In early June, tiltmeter measurements had shown that the volcano was inflating, evidently due to growing amounts of magma filling the reservoir beneath the summit. At the same time, seismic activity, previously concentrated at a depth of a few kilometres below a point about 5 kilometres northwest of the summit, shifted to shallow depths just below the summit. On June the 7th, the first magmatic eruptions took place, with the formation of a lava dome at the summit of the volcano. The dome grew substantially over the next 5 days, reaching a maximum diameter of about 200 metres and a height of 40 metres. A small explosion at 0341 on June the 12th marked the beginning of a new, more violent phase of the eruption. A few hours later, large explosions lasting about half an hour generated an eruption column which quickly reached heights of over 19 kilometres, and which generated pyroclastic flows extending up to 4 kilometres from the summit in some river valleys. 14 hours later, a 15-minute eruption hurled ash to heights of 24 kilometres. Friction in the uprushing ash column generated abundant lightning. A third large eruption began at 0841 on June the 13th, after an intense swarm of small earthquakes over the previous 2 hours. It lasted about 5 minutes, and the eruption column once again reached 24 kilometres. After 3 hours of quiet, seismic activity began, growing more and more intense over the next 24 hours, until a 3-minute eruption generated a 21-kilometre high eruption column at 13:09 on June the 14th. Tephra fall from these 4 large eruptions was extensive to the southwest of the volcano. 2 hours after the last of these 4 explosions, a series of eruptions began which lasted for the next 24 hours, and which saw the production of much larger pyroclastic flows and surges which travelled several kilometres down river valleys on the flanks of the volcano. Section 6. The climactic eruption. June the 15th saw the onset of the climactic eruption. Large tremors starting at 1342 saturated all the seismographs at Clark Air Base, and by 1430 all had been rendered inoperative, mostly by pyroclastic density currents. Intense atmospheric pressure variation was also recorded. On the same day, Typhoon Yanya struck the island, passing about 75 kilometres or 50 miles north of the volcano. The typhoon rains made direct visual observations of the eruption impossible, but measurements showed that ash was ejected to heights of 34 kilometres by the most violent phase of the eruption, which lasted about 3 hours. Pyroclastic flows poured from the summit, reaching as far as 16 kilometres away from it. Typhoon rains mixed with the ash deposits, causing massive lahars. The ash cloud from the volcano covered an area of some 125,000 square kilometres, or 50,000 square miles, bringing total darkness to much of central Luzon. Almost all the island received some ashfall, which formed a heavy, rain-saturated, snow-like blanket. Tephra fell over most of the South China Sea, and ashfall was recorded as far away as Vietnam, Cambodia and Malaysia. By about 22:30, 9 hours after the onset of the climactic phase, atmospheric pressure waves had decreased to the pre-eruption levels. No seismic records were available at this time, but volcanologists believe 22:30 marked the end of the climactic eruption. Section 7. The aftermath. In all, the eruption ejected about 10 cubic kilometres, or 2.5 cubic miles of material, making it the largest eruption since that of Nova Rupta in 1912, and some 10 times larger than the 1980 eruption of Mount St Helens. Ejected material such as tephra fallout and pyroclastic flow deposits are much less dense than magma, and the volume of ejected material was equivalent to about 4 cubic kilometres or 1 cubic mile of unerupted material. This colossal eruption had a volcanic explosivity index of 6. The former summit of the volcano was replaced by a caldera 2.5 kilometres wide. The highest point on the caldera rim now stood 1,485 metres above sea level, some 260 metres lower than the pre-eruption summit. About 300 people were killed by the eruption, mostly by roofs collapsing under the weight of accumulated wet ash, a hazard that was greatly exacerbated by the simultaneous arrival of Typhoon Yanya. The evacuation in the days preceding the eruption certainly saved tens of thousands of lives, and has been hailed as a great success for volcanology and eruption prediction. However, since the eruption, each rainy season has brought further lahars, which have caused the displacement of thousands of people. Hundreds have died from poor sanitation in relocation camps. Agriculture in the region also suffered badly from the effects of the eruption, with hundreds of square kilometres of formerly arable land being rendered infertile, destroying the livelihoods of thousands of farmers. The United States maintained 2 large air bases in the region. Subic Bay Naval Base was 75 kilometres, or 50 miles to the southwest, while Clark Air Base was a mere 40 kilometres, or 25 miles to the east of the volcano's summit. Both were abandoned after being severely damaged by the eruption. Although the 1991 eruption was one of the largest and most violent of the 20th century, it was weaker than any of the historical eruptions uncovered by geologists. There is some evidence that eruptions at Pinatubo are getting weaker over time, but this is by no means conclusively established. Section 8. Social and economic effects. The eruption of Pinatubo severely hampered the economic development of the surrounding areas. Extensive damage to buildings and infrastructure cost billions of pesos to repair, and further costs were incurred in constructing dikes and dams to control the post-eruption lahars. In total, 364 communities and 2.1 million people were affected by the eruption, with livelihoods and houses being damaged or destroyed. More than 8,000 houses were completely destroyed, and a further 73,000 were damaged. In addition to the severe damage sustained by these communities, roads and communications were damaged or destroyed by pyroclastic flows and lahars throughout the areas surrounding the volcanoes. The estimated cost of repairing the damage to infrastructure was 3.8 billion pesos. Many reforestation projects were destroyed in the eruption, with a total area of 150 square kilometres, or 37,000 acres, valued at 125 million pesos destroyed. Agriculture was heavily disrupted, with 800 square kilometres, or 200,000 acres of rice-growing farmland destroyed, and almost 800,000 head of livestock and poultry killed. The cost to agriculture of eruption effects was estimated to be 1.5 billion pesos. Damage to healthcare facilities and the spread of illnesses in relocation facilities led to soaring death rates in the months following the eruption. Education for thousands of children was seriously disrupted by the destruction of schools in the eruption. The gross regional domestic product of the Pinatubo area accounted for about 10% of the total Philippine gross domestic product. The GRDP had been growing at 5% annually before the eruption, but fell by more than 3% from 1990 to 1991. Section 9. Global effects. The powerful eruption of such an enormous volume of lava and ash injected significant quantities of aerosols and dust into the stratosphere. Sulfur dioxide oxidized in the atmosphere to produce a haze of sulfuric acid droplets, which gradually spread throughout the stratosphere over the year following the eruption. The injection of aerosols into the stratosphere is thought to have been the largest since the eruption of Krakatoa in 1883, with a total mass of sulfur dioxide of about 17 million tonnes being injected, the largest volume ever recorded by modern instruments. This very large stratospheric injection resulted in a reduction in the normal amount of sunlight reaching the Earth's surface by up to 5%. This led to a decrease in Northern Hemisphere average temperatures of 0.5 to 0.6 degrees Celsius, or 0.9 to 1.1 degrees Fahrenheit, and a global fall of about 0.4 degrees Celsius, or 0.7 degrees Fahrenheit. At the same time, the temperature in the stratosphere rose to several degrees higher than normal, due to absorption of radiation by the aerosols. The stratospheric cloud from the eruption persisted in the atmosphere for 3 years after the eruption. The eruption had a significant effect on ozone levels in the atmosphere, causing a large increase in the destruction rate of ozone. Ozone levels at mid-latitudes reached their lowest recorded levels, while in the southern hemisphere winter of 1992, the ozone hole over Antarctica reached its largest ever size until then, with the fastest recorded ozone depletion rates. The eruption of Mount Hudson in Chile in August 1991 also contributed to southern hemisphere ozone destruction, with measurements showing a sharp decrease in ozone levels at the tropopause when the aerosol clouds from Pinatubo and Hudson arrived. Another noticeable effect of the dust in the atmosphere was the appearance of lunar eclipses. Normally, even at mid-eclipse, the moon is still visible, although much dimmed, but in the year following the Pinatubo eruption, the moon was hardly visible at all during eclipses, due to much greater absorption of sunlight by dust in the atmosphere. Section 10. The area since 1991. Following the climactic eruption of June the 15th, 1991, activity at the volcano continued at a much lower level, with continuous ash eruptions lasting until August 1991 and episodic eruptions continuing for another month. Activity then remained low until July 1992, when a new lava dome began to grow in the caldera. This dome appeared to be composed of fresh lava from the deep magma reservoir beneath the volcano, rather than material left over in a shallow reservoir from the 1991 eruption. Thus, volcanologists suspected that further violent eruptions could be possible, and some areas were once again evacuated. However, the eruption did not become violent, perhaps due to outgassing from the deep reservoir reducing the explosivity of the lava reaching the surface. Since 1992, the volcano has been dormant. The Aita people were the hardest hit by the eruption. The total destruction of many villages by pyroclasts and lahar deposits meant that many Aita were unable to return to their former way of life. After the areas surrounding the volcano were declared safe to return to, those whose villages had not been destroyed moved back, but most people moved instead to government-organised resettlement areas. Conditions on these were poor, with each family receiving only small plots of land, which were not ideal for growing crops. Many Aita found casual labour working for lowland farmers, and overall Aita society became much more fragmented and reliant on and integrated with lowland culture. After eruptions ended, a crater lake formed in the 1991 caldera, with the 1992 lava dome forming an island. At first, the lake was small, hot and highly acidic, with a minimum pH of 2 and a temperature of about 40 degrees Celsius. Abundant rainfall cooled and diluted the lake, lowering the temperature to 26 degrees Celsius and raising the pH to 5.5 by 2003. The lake increased in depth by about 1 metre per month on average until September 2001, when fears that the walls of the crater might be unstable prompted the Philippine government to order a controlled draining of the lake. 9,000 people were once again evacuated from surrounding areas in case a large flood was accidentally triggered. Workers cut a 5-metre notch in the crater rim and successfully drained about a quarter of the lake's volume. External links: Mount Pinatubo, http://volcano.undig.edus/VOLC_image/southeast_Asia/Philippines/Pinatubo.html. Weather effects of the 1991 eruption. http://eos.higp.hawaii.edu/education/slide_set1/ CVO Pinatubo Photo Archive. http://volcano.wr.usgs.gov/volcanoes/Philippines/Pinatubo/images.html. News article about the draining of the crater lake. http://uk/1/hi/World/Asia-Pacific/1530182.stm. This sound file and all text in the article are licensed under the GNU Free Documentation License, available at www.gnu.org/copyleft/fdl.html.